everybody, I hope we are all doing well. I know this does not look like my normal classroom. I am hiding in like a science lair, I guess you could call it. Nonetheless, I'm still here to make a quick video on what you need to do for today's or this week's e-learning checklist. So we're kind of in the midst of our How do Storms Form unit, and through this we are going to get through a couple labs and a couple activities that we can do. So the first thing that we're going to go through is kind of some of the information that you need to use on your Steps to Storm Formation scientific principles sheet. So I'm going to go through a couple slides that I'm going to stick up on the screen here, and you can take notes on this. You can pause the video and make sure that you write them down in your scientific principles sheet. And basically it's going to be 7 and 8 are going to be the steps that are going to be answered in this video, and they're going to help you kind of start to understand how storms are formed, and a couple other things that happen revolving around air pressure and what's important to know through air pressure. So as we progress through this, I am going to also explain how your lab for this week, which is activity 4.2, this is named How Does Altitude Affect Air Pressure? This is something that you can see in your lab packet currently, although I do not suggest that you use that sheet because I actually rewrote this lab so you can do it in your home without having to be in school or being anywhere near other students right now while we were at the stay-at-home order. So you can look at this quickly if you wanted to get kind of a clue on what was going on here, although this data table and instruction sheet doesn't really matter to what we're doing. Like I said, I rewrote the lab for you all so that you can do this at home and kind of have like a fun activity to do with this. So let's start first. I'm going to go through the scientific principles, a couple other slides that we're going to need to know, and then if you stay tuned at the end, I'm going to do a pretty cool demo that has to do with air pressure. See you there. Okay, so now that you've made it to this part of the video, we're going to start kind of putting up the keynote slides that you would have seen in a presentation in class, and talk about kind of what those have to do with activity 4.2 and learning about how storms form in terms of air pressure. So the first slide that I'm going to bring up, and it's going to take over my screen, is going to be something that's a storm model. And in this model we have a sun that's up in the top right corner. And then we have warm air and cold air. Now, if you notice at the bottom of the screen in this picture, the snow-covered land is where the cold air is hitting, and then the dark or paved land is where the warm air is hitting. So if you look, we kind of zoomed in on those two things there and gave you two little circles, and they show the air and what it's basically doing. We have the warm air and we have the cold air. That's the blue dots and the red dots. Now, fast forwarding a little bit into our storm unit, we have a word wall word, which is going to be the next slide that's on the screen. That word wall word is convection. Convection is the circular flow of air from the ground into the upper atmosphere and back down again. So something that's kind of interesting that we're going to talk about is that this is a whole system. If you haven't been able to take that out of what we've been doing in activities, is that storm models are kind of a system. They have this kind of a repeat thing. If you think of like the reduce, reuse, and recycle sign, it has those arrows that kind of go in a triangle fashion that make us reduce, reuse, and recycle, and then we repeat that. So this is how the storm model is formed, is through convection. So the picture that you're looking at now is that same storm model picture, but we've added a couple more arrows. We have an arrow that is red that's going from the warm air, so it's coming off of the dark soil or paved land, and that is an updraft. That is the air going back up into the atmosphere. It's basically going up. Now, we have some winds that happen in the upper atmosphere, which is the other red arrow. That is the upper winds. The upper winds take it and they slide it over this way until it becomes cold air. The upper winds move it up into the atmosphere, and then it's sliding over through the upper winds. Now, Once it's reached a point where it's no longer warm, it becomes cold air, which we see in our part of our picture that has the cold air and then a arrow pointing down that is called a downdraft. So basically, warm air goes up into the atmosphere, it gets shifted over by upper winds, and it becomes cold. And when that happens, it goes back down to snow-covered land or colder land in a downdraft. That's where we get that term that's in the blue arrow. Now, there are surface winds, which are things that we feel, and they move that air back over into the warm air area or to dark soil or paved land. So we have this huge kind of reoccurring circle of warm air going up, being pushed over, coming back down as cold air, and going over with the surface winds pushing it. And through this, the air is changing temperatures. It's going like this, basically, and going in a very large circle, and that is called convection. It's a circular flow of air. Now, moving on to the next slide that you're going to see, you are going to be able to look at the storm model again and actually see the arrows in use that we talked about that are kind of like the reduce, reuse, and recycle arrows. They are low pressure systems and high pressure systems. These are the added graphics, the H and the L, that are in that picture, and they are allowing us to see that this is, once again, a circular flow of air that's going up near the sun, getting hot, getting pushed over, getting brought back down in a high pressure system as cold air, and then being pushed over by surface winds so that it can become a low pressure system and have warm, moist air again to go back up into the atmosphere. It's that big, big circle that we're talking about. You can kind of see it being drawn with the red and blue arrows. So, how does this relate to our scientific principles? Well, in your scientific principles, you have a sheet that says how to form a storm. So, taking a look at scientific principle number 7, it says, and I'll put it on the screen so you can all write it down and pause if you need to, that warm air rising creates areas of low pressure, while cold air falling creates high pressure areas. Once again, if we look at those storm models, if you have to rewind and go back in this video, and I can even put this up on the screen at this point again, the warm air rising, that air that's going up into the atmosphere, is creating areas of low pressure, and then when it gets shifted over and the air comes down as cold air, it creates areas of high pressure. That's going to be scientific principle number 7, or step number 7 in forming a storm. Now, if we progress on to scientific principle number 8, we have our 8th step as warm, moist air rises and loses pressure, which causes water vapor to condense into clouds. Now, in your previous steps, you've learned that clouds have water vapor in them. Also, you've learned that there's water present in the system. That's how we have snow, that's how we have rain. And so when we talk about this, and this step number 8 is that where do those clouds come from? Where do we get the storm formation from? And that is the warm, moist air losing pressure. It goes up into that atmosphere, which causes the water vapor to condense into clouds. So when that warm air goes up into the atmosphere, it actually is forming clouds, which is how we get the start of storms. And as you progress through this lab, you will see that we will talk more and more about how that plays a role in storms forming. Now, I'm going to move on to the fun kind of demo that we have planned for this week. And this is just kind of something to keep in the back of your head since we are looking at the air pressure portion of this unit. So what I'm going to do is I'm going to start my next video in a different environment. I'm going to start in my kitchen, and I'm going to show you all a way that you can demonstrate air pressure, and I'm going to ask that you please don't do this at home. I would like you to watch the video and kind of just think about what's happening in the video. When you get to lab 4.2, once again, we talked about it in the starting video, that one that I am rewriting. You need to go on your checklist to get the correct version of this. There will be some questions that have to do with this demo, so make sure you're paying attention. and it will be a very fast-paced demo, but something that's pretty cool that you don't think could happen, but happens, that has to do with air pressure. I'll see you there. Okay, everybody, so now we are moving on to the portion of the video where I get to do kind of the fun demo. So what we have here is we have a container full of regular, lukewarm water, about 100 milliliters. We have an empty pop can, and then we have a bowl of cold water, and then I have some tongs. So what we're going to do is we're going to take our container and we are going to fill the pop can with our 100 milliliters of water. Now, once again, this is just regular temperature water that comes out of the sink. It's not cold or warm. And what we are going to do is we're going to take that can and we're going to place it on our oven. Now, I'm going to light the oven and I'm going to leave it at about half of the heat. And what is basically going to happen is we are going to watch at the top portion right here until we see some smoke coming out of the can. Now, when that happens, we are going to take our tongs and we are going to put the can into the water upside down. And you are going to see how a reaction happens with air pressure, and we can crush the can without even touching it. Alrighty, so we are at the point where we are going to take our can and we are going to place it into the bowl of cold water. Now, it's kind of hard to see at the moment the water vapor coming up, but right around here there is some smoke that is occasionally coming up, and you may be able to see it briefly. But we are going to shut our burner off and we are going to quickly take the can and place it into the water. So here we go. And just like that, our can that was whole, placed in water, has now been crushed just by dumping it upside down into our bowl of water. As you progress through this lab, you're going to see how air pressure plays a role in weather systems, and how something as simple as this can being crushed in cold water is related to warm, high pressure systems and cold, low pressure systems, all interacting in a circular motion, convection, and creating a storm. Best of luck on the lab, guys. Good luck with this week, and stay healthy.